Today's problem will deal with how we can calculate the speed of a ball 30 degrees below horizontal. And it's going to be a ball swinging in a circle like this. And we're going to be given that the speed at the top is going to be 3.26 meters per second. And that we know the mechanical energy through other given factors I calculated earlier. Mechanical energy at the top is going to be 4.3 joules. So how do we find the speed of a ball 30 degrees below horizontal? There are two ways you can do that. Because the question that we have our hand is going to seem a little more complicated. We're going to be told that the height of a center of a ball from the ground is going to be, the height from the center to the ground is 1.5 meters. And we're also going to be given the radius of a string is 0.7 meters. And the mechanical energy at the top that we got from the question is going to be relative to the floor. Okay. I'm going to jump to a quick way to solve for this. Okay, so it seems like we're going to use conservation of energy, but first, let's calculate this little height here, because that will be quite important. If we're going to use a conservation of energy, we are going to have to use this expression, because energy in this system is conserved, and the potential energy plus kinetic energy will be equal to the potential energy plus the kinetic energy of the second position. Now the question lies in what should we put in for the height of the potential energy, because everything else seems pretty simple. Okay, let's say this is 0.1 and this is 0.2 of interest. Let's just substitute everything we have in. So the potential energy, the quick way to solve for this, I'm going to go like that. You can make a reference point. You can make a reference point that this spot is going to be height 0, because in our question it's not going to go lower. And you can say that this height can be given a reference point of, let's see, it's going to be 0.35 plus the radius of the string, so that's how high vertically it goes, right? That's a change in height, so that's what we end up getting. The change in height is 1.15 meters. Okay, so then the fast way to do this is, we know the potential energy's height is going to be 1.15 meters. And you can just put the m and g in here. I won't do that since I've already have it calculated, but you can do that. I'm just showing you the confusing parts. And 1/2, you know the mass. The mass I forgot to give to you. It's going to be 0.16 kg. So you can put your mass in, and the velocity at the top squared is 3.26. And for potential energy 2, since according to our reference point, the height is 0, so height is going to be 0, so the whole thing is going to be 0, plus 1/2 the mass, and the velocity is what we're looking for. Fantastic. So if you isolate everything, if you substitute all these values in, which I can do here, and then you isolate for this, what you should end up getting is a speed is this. So then this is an easy way to use a reference point for height so that you don't have to calculate so much. But since we're given the mechanical energy at the top in reference to the floor, and if you had to use that given, here is the other way that you can solve for it. Okay, so then the height won't be like this anymore. Okay, change color. Okay, so we still gonna know that this is gonna be mechanical energy 1 equals mechanical energy 2, and 1 is the top, 1 is the second part is 30 beneath horizontal. EP plus EK, this is a mechanical energy. Okay, now this time for MGH and MGH here, you're still going to drag all that down. Just doing that really quickly because that part's not too bad. You end up calculating for this, and you have all of this, you have all this. Okay, the height for potential energy 0.1, well, actually, take a look here. We are already given the potential energy, the mechanical energy at the top. So we can just say this entire thing here is 4.3 joules. But if you weren't given that, you could still put the height in here, which would be 1.5 meters plus 1.5 meters from here to here, and then 0.7 from the top to the radius. So then if you were to put in for height, a height would be that, okay? 1.5 plus 0.7, but since we're given the mechanical energy of 1, it's gonna be 4.3. Now the height of a second object at 30 below horizontal. Let's see. The height below horizontal is 0.35. So the height above the floor is going to be the radius to the bottom of a floor minus the radius from the bottom of the floor. And then since we're looking for the height from where the pendulum is to the center, the imaginary center of a circle is 0.35. If you're given 1.5 like this, and you have something at 0.35 here, then you're obviously going to look for this height. This is a height above your reference point, in this case, which is a ground, which is just a little bit more difficult than what we did in first step. So that means that we're going to use 1.5 meters minus 0.35 meters. Okay. 1.15 meters. And then you're still going to have your MGH and then all of this stuff. But I just showed you how to find the height here because everything else is pretty plain. And what you should end up getting in the end should also be the same thing.